So, welcome everyone to Guided Study Group Week 12 of Mat 141. And so today we're going to have the final exam review of Mat 141. So kind of like I'm just going to go through a checklist of materials whatever you guys should review for the final exam. And then we're going to go through the questions from the practice exam. And so the review after exam 2. So after exam 2, things that you guys need to pay attention. Oh yeah, by the way, anyone who hasn't put their PSU email in the chat room, please do that for me. So after exam 2, we work on Taylor-Maclaurin series, just kind of like find a power series representation of whatever functions that were given. And those things related to the radius and interval convergence, and we're gonna find them using the ratio test, and also test it at the endpoints of that intervals. Also understand what is the center of the interval convergence. Find the Taylor-Maclaurin series or power representation of a function. And so this one, as I mentioned, we should have noted down some of the power series representation that we already learned throughout the semester. So far in my list and also from the book, I have the series. So let's type them out. So I have 1 over 1 minus x plus or minus 1 over 1 plus or minus x squared, ln of 1 plus or minus x, inverse tangent of x, e to the x, sine x, cosine x, and then ln of 1. Oh, that one we haven't really covered, so that one is all of the all of the functions that I have the power representation of. And so next one is find the sum of a series by putting in Taylor-Maclaurin series. So kind of like we have usually if we're gonna be asked to find a sum of a series. Either we use what we learned in midterm 2, geometric series, or try to put it in harmonic series and find things that cancel out. In the part that after exam 2, we can also have another method. It's by putting everything back into their functions using the Taylor-Maclaurin series representation. And then we're just gonna say we put like a series equal to some function, and then at some x equal to a, and then we resolve for that. And then the last part is to write the nth degree Taylor polynomial of a function and use that to approximate our function, and also estimate the maximum error of the approximation. Then parametric curves that we cover, how to sketch them, find the initial and terminal points, the direction, kind of like the basic of parametric curves, and also how to apply it. So the most basic thing of any kind of functions that we're going to learn is to find the derivative and also the tangent line. Then lastly, we have polar coordinates, curves, and area. So this one is kind of like introduce us to a new coordinate system, which we're going to continue learning if you guys proceed to 230 and 231. Where we're going to learn about shape of polar curves, how to sketch directions, special points, and frequency. And so I already mentioned we should also have a list of the common trig functions like cosine 3x or sine 3x, sine x, cosine x, and also maybe those things plus or minus 1. And also we have things like others, maybe like cosine 2x and sine 2x as well, to put in to kind of like go through in the exam and it makes your life easier because then you know the shape of the functions that you're looking at, and so you can easily draw them, and so also it's gonna help with finding the area of the regions by the two polar curves. Also be able to convert it between Cartesian equations and polar coordinates. And so that is the thing that we need to focus after exam 2, and this all of this part is gonna account for 60% of the final exam. Usually we're gonna have 40% of the final based on whatever we learned before midterm 2. And so it's gonna have 7 indeterminate forms of limit. You guys already reviewed that for midterm 2, so it shouldn't be a new thing. We also have inverse function, derivative as a function, domain, range, right triangle formula. So this is kind of like the first thing that we learn in this course and materials of midterm 1. Improper integrals, type 1 and type 2, also from midterm 2. Different integration techniques, so like those kind of trig function, trig integrals, trig substitution, partial fractions, also some other techniques we learn for midterm 1. So all of the things about integral. And finally, sequence and series, also the materials of midterm 2. And so this entire part is gonna account for 40% of the exam. So you guys kind of like, if you review what we have learned so far before midterm 2, then you can have around like 40 over 100 points in the exam. Now let's go to the questions from the practice exam. Just give me a second, I need to, okay. So we have, you have fx equal to inverse sine of 2ex. Find f prime of ln of 3 over 10. And this one is kind of like I want to review one of the law that we have about inverse function in midterm 1, which is going to be if you have f prime of inverse function of x, we have this one is going to equal 1 over f prime 1 over f prime of, hang on, maybe I think I make a mistake typing the materials out in a sense, because this one doesn't match with any of my answers. Pretty weird. So this one I'm gonna have, anyway, let's go do this. Give me a second to retrieve any general idea of how to finish this one, because I couldn't find where I wrote it down to finish this. I have this one equal to that. Because I remember one of the law about finding the derivative of your functions from whatever we have earlier. Okay, so I think I understand what's going on right now. Okay, in this one, not the law, because I don't think we covered that in this Math 141, but we do in the spring. And so this is a mistake that I mistyped in the, okay. So what happened is I want to retrieve what is the sine, what is the derivative of inverse sine. And so we all have inverse sine. Derivative of inverse sine is going to be the derivative of 2 to the ex divided by square root of 1 minus. Yep, 1 minus 4 e to the 2x. Okay, now we're just gonna plug in to find what is the derivative of that. Oh, this one is, this started with e2 to the ex square root of 1 minus 4 e to the 2x. And so this one we're gonna have 2 multiply 3 over 10 square root of 1 minus 4 e to the 2x, which is going to be 3 over 10 square. And so what we have here is going to be 3 over 5 square root of 1 minus 4 multiply 9 over 100, which is 36 over 100. The thing inside the bracket is going to give me 64 over 100, and take the square root, that's going to be 8 over 10, which is also 4 over 5. And so we end up having 3 over 4. Okay, yeah, sorry for the kind of like confusing start of the review. But then, yeah, that is what I want to try to deliver. And also, besides inverse sines, you guys should review what is the derivative of the inverse of tangent, inverse of cosecant, inverse of cosine as well, and also their domain and range. Yeah, that's what I have for question 3. So nothing really new, but more like review the derivative of these inverse function. Question 5, evaluate the integral from 0 to square root of 3 of 2 inverse tangent x over 1 plus x squared dx. So this one is going to be a very quick use up, where you have u equal inverse tangent x. And so you're going to have, if you want to do the change of variable as well, instead of putting everything in x, you have to change it from x to u. Here I have du equal 1 over 1 plus x squared dx. So if you have inverse tangent of 0, you're going to have u equals 0. Inverse tangent of square root of 3 is going to be pi over 3. Because that's going to be sine of pi over 3 over cosine of pi over 3. And so your integral now becomes 0 pi over 3 2u du, which is now going to be very simple. 0 pi over 3, which is going to give me pi squared over 9. So this one, again, reminds us of the derivative of some inverse function. Now let's go to question 9. Determine whether the given sequence converges or diverges. And so it's just a quick way to remember this. If you want to find if a sequence is converges or diverges, the thing that you need to find is find the limit of n approaching infinity of an. And so you're going to have limit of n approaching infinity here, the free n root of a to the n plus a to the 2n plus a to the free n. And so what I'm going to do is that I'm going to take n to the free n out to cancel with the free n root outside of that. And we're going to have inside is 1 over a to the 2n plus 1 over a to the n plus 1. Now, because this part is going to cancel out, what we end up having is that we're going to have limit of n approaching infinity, 8, because a to the free n and to the free n root is going to be the free n root here of 1 over a to the 2n, 1 over a to the n plus 1. And it ends approaching infinity. This one's approaching 0, this one is approaching 0. And then you have 1 to the free n root, which is gonna approaching 1. Because whatever root that you take of 1 is gonna approach 1. And so what we end up having is going to be 8. And it is a constant, so our answer is that this sequence converges. But if you have a series, finding this is going to give you a divergent series, because the limit of n approaching infinity of an by test of divergence is not 0. So it's going to be divergent series, but convergent sequence. So if you don't have any other questions with this, let's go to the next one. Consider this series going from n equals 0 to infinity. 1 over 1 plus c to the n. Which of the following statements true? The series is geometric for every choice of c different than -1. So let's think about every constant of C different from -1. Whatever inside this bracket is just going to be a constant, and it's to the n. And so this is true that this is going to be a trigonometric series. Now second, the series converges for C equal -1/3. So when C equal -1/3, our series become 1/2/3 to the n, which is going to be the series sum of 3/2 to the n. And so if you look at the fraction inside, 3/2 is bigger than 1. And so we conclude that this series is going to be divergent by trigonometric series. And so the second statement is wrong. Now let's look at the third one. The series converges to 2 when C equal to 1. C equal to 1, the series is going to be half to the n. And so to find the sum of this series is going to be our first term minus the factor that we multiply, which is going to be 1 minus half here. And for A, it's going to be whatever value end up with when we plug n equals 0 into this entire fraction. When n equals 0, you're going to have that 1's equal to 1. So you have 1/1 minus half, which is 1/2. One's divergent. So it's going to be 2. And so the third statement is correct. So when you choose your answer choices, this should be the first and the third statement are correct. So pretty easy, just a quick review of what we should need to know about trigonometric series, how to find its sum, how to identify the factor, and try to identify when it converges and when it diverges. Now question 13, find the interval of convergence for the power series. And as I briefly mentioned in the review that we just have, just in the checklist, to find out we're going to use the ratio test. So let's find the limit of n approaching infinity of a fraction of the absolute value of an over an plus 1 over an. So you have limit of n approaching infinity. So when we take the absolute value, we can ignore -1 to the n because that's just going to be 1. And so what we end up having is that we have x plus 2 to the n plus 1 divided by n plus 1 for n plus 1 multiply x plus 2 to the n divided by n 4 to the n. And as n approaching infinity, let me rearrange this part to make life easier. You're going to have absolute value of x plus 2 divided by 4 multiply absolute value of n over n plus 1. So that's when I cancel out some of the terms and end up with the most simplified version. And that's n approaching infinity. Limit of n at n approaching infinity, limit of n over n plus 1 is going to approaching 1. And so what we end up having is x plus 2 over 4. And this one, by radius convergence, has to be smaller than 1. And so we have x plus 2 smaller than 4. So our radius convergence is 4, and the convergence series is going to be -4 to 4. Or you have that one from -6 to 2. Now let's check at the end point where you have x equal to 2 and x equal to -6. This one we're going to end up having with the series of -1 to the n, 4 to the n over n 4 to the n. And we have this series -1 to the n over n. And this one is convergent by the alternating series test. Then if we have -6, we're going to have -4 to the n and multiply 4 to the n, which is going to give me the series of 1 over n. And this one is the harmonic series. And so this one is going to be divergent. by P series or by harmonic series, whatever it is. And so our interval of convergence is going to be just including the 2 points, which is the value 2, so it's -6 to 2. Is that clear how we get it? Feel free to have questions to me during the sessions if you feel like it's confusing or something. But for now, we should be pretty clear with this part. The only thing that I think that we're gonna struggle is to find the power series representation of some function and using all the Taylor and Maclaurin series. And so if you guys need more practice on that, please do that. But don't stress too much if you don't know how to do it or like kind of like struggle, because that's just gonna be like some questions in the final exam, so it shouldn't be too bad. But yeah, if you don't know how to do it and still struggle, there's a high chance that you're gonna lose the points on that part in the exam. Is one also divergent because P series. That is true. That is also divergent because P series. So that's what I'm saying. You can do harmonic series or divergent by P series. Okay, so let's go to question 15. If the radius convergence of the power series is 9, so this one have the radius of Cn x to the n, radius of 9. What is the radius of the convergence? Cn x to the 2n. So similarly here we have, for this function, we have absolute value of x smaller than 9, so that is the radius. Here we're gonna have the same thing when you go from this to this, because this series is basically the initial series and you take the integral of that. So take the integral. And so we have the law or like the theorem saying when you take derivative or integral of some series, the radius of convergence doesn't change, but the interval of convergence may change. And so you're gonna have the same thing, the radius with whatever fractions that we end up having here is going to be x squared smaller than 9. So your actual value of x is going to be smaller than 3. And so the radius of convergence of the second series is going to be 3. Note to find out what I'm starting with right now is looking at the fraction. Here is x to the n, meaning when you take the ratio test and you have the radius equal to 9, which means when you take the ratio test, what you end up having is absolute value of x smaller than 9. So when you have x squared to the n here, when you take the ratio test, what you end up having also is x squared, the absolute value of x squared, and that's going to be smaller than 9 as well, because the radius doesn't change when you go from this to this, even though the expression that you use to calculate the radius change from absolute value of x to absolute value of x squared. And so the radius is going to be 3 in this case. Yeah, but then the radius of whatever fractions that you end up having. So what I'm saying here is looking at the radius here, right? Your ratio test gave you absolute value of x smaller than 9. That is what's given in the, this is what is given in the problem statement. However, when you take integral of that, you end up with x to the 2n. And so technically, the radius of the series doesn't change, it stays at 9, but the fraction of u change. So like whatever expression that you use to calculate after you get the ratio test, change from absolute value of x to absolute value of x squared. So when they say the radius equal to 9 in the problem statement, it means two things. When you take the ratio test, you end up having whatever fraction to the n power, which is absolute value of x, and it's smaller than 9. So when you take the ratio test for this part as well, then you're going to have the expression of a radius be absolute value of x squared smaller than also 9. And so from that, you proceed to absolute value of x smaller than 3, because the radius we're looking for is with respect to x and not with respect to x squared. Therefore, our actual radius is going to be 3, but the radius of the series, based on, you see the logic here that I'm talking about? It's kind of like abstract, but yeah. Okay, so that one is absolute. Okay, so let's go to question 15. I kind of like struggle with this question. I kind of like struggle as well at the beginning because I was like, okay, I need to understand this logic. I got it wrong, so don't freak out if you also get it wrong, because I also need to look at the solution to see what exactly is the mindset that she was thinking when she wrote this question. So question 16, find a power series representation of this part. And so this one is where it comes to the list of power series that you guys already have so far. And so what I did is that I'm just gonna apply one of them. And so if you guys haven't got all the series that I noted down in the checklist before, try to go through all the lecture notes after the midterm too and find all of them, and including your practice problems, because when you have that list, it's going to be really quick for you to review for the exam. But if not, it's going to take you a lot of time to just look at the slides again and find that series representation, which is going to take so much time for you to review. And so we have fx be x over 1 minus x squared. And this one, I'm going to take x out and put the series of 1 over 1 minus x squared. So I'm going to have x multiply the series from n equal 1 to infinity, n multiply x to the n minus 1. So that is the series power series representation of 1 over 1 minus x squared. And you can also go find that one from the power series representation of 1 over 1 minus x, which is going to be the very basic one that you already have, x to the n. And so with that in mind, I'm just gonna multiply this x inside. You're gonna have n x to the n with all x in -1 to 1. And that's our power series representation. So you kind of like have a general idea of what to expect of power series representation in the exam. It's not gonna be extremely difficult, or just challenging in the exam. It should be pretty much basic because you're gonna have all sections to focus about in this course. And so putting everything super complicated on just one section is not a very good way to write exam. So don't stress about this thing too much. Now let's go to question 21. Find the derivative for this parametric curve. And so you have dy over dx is going to be, it's going to be a really quick one, but give me a second to plug in the computer. I have a really strong feeling that's going to die at any moment. Okay. So you're going to have that equal dy over dt divided by dx over dt, which is now going to give us sine t, negative sine t, which is going to be derivative of cosine t, and derivative of inverse tangent is going to be sine t, take the derivative of that, over 1 plus sine squared t, which is going to give us negative sine t divided by cosine t multiply 1 plus sine squared t. It's going to give me negative tangent t 1 plus sine squared t. So nothing really new, but it combines the definition of derivative in parametric curve with the derivative of some inverse trig function. And so remember here, the thing inside the bracket is not simply t, but it's sine t. So you have to include this sine t derivative of that because of chain rule. Now let's go to 22. The curve with this equation r squared sine 2 theta equal to 1 in polar coordinates is whatever curve it is. And so we have to identify it. So there are two ways you can do it. Either you graph it out, which I think is going to take a lot of time, or put it in Cartesian equations, and that's going to be much easier because you already know the shape of many functions in the Cartesian equation, especially when it comes to r squared or anything relates to r. Unless you have things like r squared, r equal to sine 2x or sine 2 theta or sine 3 theta, then those things are very easy because you already have a list of them combined together from math one, from the lecture notes and also from the practice problems. But here, when it comes to something like r multiply a function of theta equal to some constant, it's usually easier to put it in Cartesian equation. And so in this case, I'm gonna put it in Cartesian equation, but let's start it with expanding sine 2 theta. So we have r squared multiplies 2 sine theta cosine theta, because that coming from the definition of a double angle trig. And so we have here, I can take 1r in 2r sine theta, multiply r cosine theta equal to 1, which I'm going to have 2xy equal to 1. And so you also write it as 1 over y equal to 1 over 2x when x is different from 0. And so this one we already know from even before we take this course that this is a hyperbola. And so we have the answer for this in a minute, instead of trying to graph it out using tables of values. And so we have that is question 22. So one of the techniques to identify what is the curve, besides having a list of all the curve together and just compare them, is putting it into Cartesian equations and identify it as one of the familiar curve that we already learned even before this course. Now, let's go to the last questions that we have in this exam review. Set up but do not evaluate the integral expression for the area that lies inside both curves. R equal 1 plus cosine theta, which is going to be this one, r plus 1 cosine theta. And the one on the left, which is going to be r equal 1 minus cosine theta. And so the integral in between the area that lies inside both curves is going to be this area and this area. So there are multiple ways that you can find it. For me, I usually enjoy doing symmetry. And so I'm just going to find the area of one single part and multiply it 4 times. And by doing that, let's find what is the boundary between this point and this point. So let's see with r equal 1 plus cosine theta. So when theta equal to 0, so let's start here. When theta equal to 0, it's going to be this one, and for red, it's going to start from there. And then when you go to theta equal to 1 to pi over 2 here, then your r is going to be equal to 1 for both of them. And so you can find the area of each very easy. Now let's start with finding the one on the right that I mark up. It's going to be the integral from 0 to pi over 2 of this curve bounded with, so it's going to be this curve bounded the outer radius, and the inner radius is going to be just 0. And so outer radius is the red curve, so it's going to be 1 minus cosine theta squared d theta. There's another way to find. You can find the area of the one on the right, which is going to be this part. So it's going to be 4 of half, which is this one's just going to be 2 of this thing. So it depends on whatever is given as your answer choices that you're going to find the corresponding integral. Because sometimes they give you what this one, and sometimes give you what I'm writing out. So it's you need to find what is the boundary here to here. So this is pi over 2, and it's going down. This one's going up. It's going down to this point as when theta equal to pi. So I'm going to have also the integral from pi over 2 to pi of the outer radius is the blue curve. It's going to be 1 cosine theta squared d theta. And you multiply 4 of that. So what you end up having either in this form or in this form, it doesn't really matter, depending on what you're given in the questions. So that's kind of like mark up my final exam review. Is there any questions so far with what we've done? Or you need some help on any of the problems? Let me know now. Other than that, I wish you guys luck to finish your exam. Finally, finish Math 141. Number 18. Can you have the question typed down in the one, because I don't have Canvas on my phone and the computer is assessing that one. It might take some time for me to pull it up. But if you can type it out in the chat room, that would be awesome. But let me let's hang on. Not breakout room. We need to shift the index for a power series. We do only when we take derivative of a function. So say if you go from things like 1 over 1 minus x to 1 over 1 minus x squared, right? So here you have the starting point at n equals 0. Here you're going to have a starting point of n equals 1, because the right is going to be the right is going to be the derivative of the left. Express the integral of x sine s Maclaurin, x sine x over 3 dx as the Maclaurins. Okay, give me a second. I'll make a new slide. Keep this and add a new slide here to do it. So before, it's going to be question 18. Oh, sorry, new slide. So question 18. And so let's start it with, oh, what exactly did I just do? Okay, so that one, let's see the questions again. Express integral of that as Maclaurin. So you have this one. Express sine x multiplied sine x over 3 dx as a Maclaurin series. And so what happened? Okay, I'm gonna put, I know the Maclaurin series representation of sine. And so what I do is that, let me write down here, sine x is going to be the integral, no, the series of n equals 0 to infinity, negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. That is the Maclaurin series representation, because as you can see here, you only have x and not x minus a, with a be the center of the interval of convergence. And so this is the Maclaurin series. When you have its center at some other value, like say center at a, then you have Taylor representation, right? And so yep, that is the power series representation. And so in this case, I'm just gonna plug it in with, instead of x over 3 here, I'm gonna replace x over 3 with everything related to x. So x over 3 to the 2n plus 1 divided by 2n plus 1 factorial dx. And so let's put the series in a easier form to find. So you have x to the 2n plus 2 over 3 to the 2n plus 1 multiply 2n plus 1 factorial dx. And as I mentioned, when you take integral, you only cares about the part that related to x. Anything else, you put it at a constant. And so you have that one is going to be the series of negative 1 to the n, 3 to the 2n plus 1, 2n plus 1 factorial, and you take the integral of x to the 2n plus 2 dx. So what we end up having right now is that is going to be x to the 2n plus 3 plus c. That is the, so going from here to here, the power changes. Oh, also you need to divide it by 2n plus 3 plus c. So that is what I have for the answer. Is that the answer that you have in the questions? Is there any questions that match it with that one? That's a better way to ask. Does it help with how I solve this? So basically you have the list of all of the power series representation, and now your job is just to plug them in, because yeah, you don't need to derive them again. It's going to take so much time, and the book already did that for you, so there's no need to do that. Kyrie, can you do an example on how to shift the index, please? Do you have any questions in the, like, a question of how to shift the index in the final exam? Because I cannot really come up with one right now. Couldn't really think of anyone, actually. Let's find it in my practice problems. Yeah, I mean, because technically when you have all the series that you already have, so if you look at the list that I mentioned, I have things that you're going from ln of 1 over 1 plus or minus x, and when you take derivative of that, you go to 1 over 1 minus x, and then when you take derivative of that again, you go to 1 plus or minus x squared, right? So that's like a very easy way for you to remember. When you just keep taking derivative, it's going to go to a higher degree. But or like when you try to derive them, it's just gonna shift to but here, when you go from here to here, that's a special case, because this one, the series is given by the book, and this one is also given by the book. You can derive them by taking derivative of one and go from the other, but that's not really helpful, because you might miss some, because this is going to like the advanced math level, so I wouldn't really dig too deep into that. Just kind of like a thing to remember is wherever you go, my so for things, okay, let's look at my list. The thing that I have the starting point, so for series like 1 over 1 plus or minus x, and sine x, cosine x, ln, oh, do not put that one in, that's super confusing, and inverse tangent of x is where I have the starting point of n equal to 1. But then the rest, when you have ln of 1 plus or minus x, or 1 over 1 plus or minus x squared, these I have starting point of n equal to 1. Does that help with how we do these things? And so the expression for the their power series is pretty easy to put as well. Kyrie, what do you mean by I don't know if that will show? Number 14. Let's try doing that one. Again, let me create a new slice. Okay. Oops. Hey, that's bad. Drop the pen. So, and showed. Keep that notation. Add in a new slide. Put this below this. Question 14. Nope, I don't want to exit that. Let's type it out in the chat room. Let's see what is question 14. I know which star 0. I know we did a few questions during one lectures by needing to shift the index in a problem. Can anyone type in what exactly is question 14 in the chat room? Or maybe it will be best if I actually put up in the answer choices. Okay, let me put it down. Okay, and so save this notation with everything we have had, and then let's go to Chrome. take a while for me to put in my. Ugh. What the heck is that? Oh my god. Okay, that sounds horrible. Give me a second to pull it up. Is that really horrible to look at? Modules. I don't think that shows any kind of questions that asking you how to find a power series represent find a radius of interval convergence doesn't really show the shift of index. Oh, okay. So I understand what you mean, Natasha. So the thing that we're gonna learn thing about needing to shift the index besides the series that we already have is where you try to derive them on their own. So say maybe find a power series representation of ln of 2 plus x. And so when you, oh no, maybe not ln of 2 plus x. Maybe find a power series representation of, I think what we learned in that section is maybe 1 over 3 plus 2x squared. And so to do that one, give me a second. I'll find okay. So there's no need to solve question 14, right? Which I can use it to. Okay. So let's do extra shift of index. Okay. Let's do that, and then let's do this thing. Ooh. So say maybe find a power series representation of 3 plus 2x squared, right? Oh my god. So if you do this one, so say you know that this one, there are two ways to do this. Either you put it as whatever series you already have, so two ways. You put it as 1 over 3 squared, which is 9 outside, and what you end up having, or not 9, you have is as divide everything by 3. So you have 3, oh yeah, 9 actually. 1 plus 2x over 3 square. And so you use 1 over 9 multiply 1 plus 2x. And so you find the power series of this, which is going to be the power series representation of, so it's going to have the starting point of n equal to 1, negative 1 to the n, 2x over 3 to the n, and then n plus 1. But there's another way to do it where you go from this one, you go from the derivative of 1 over 3 plus 2x squared, 2x, and you take derivative of that. So when you take derivative of 3 plus 2x, you have to multiply some constant here because you're going to have the chain rule. So this one is square, and then you have 2x plus 2, 3, 0, 1. So you're going to have negative 2. So it's going to be negative 2 over that. So this one is going to be negative 1 over 2. So you multiply the inverse of that. So when you take derivative, or you have this expression give you 3 over 2x squared, negative 1 over 2, 1 over 3 plus 2x prime. And so you can start it from here, and whatever you need is just now the n equals 0, n equal 1. Because now you take derivative, and you take derivative of this function. Oh, okay, let me start it slowly. So you're gonna find a series representation of 1 over 3 plus 2x, and then you take derivative of that, which is going to give you here negative 1 to the n. Just use the bracket. 2x over 3 to the n, and then you take derivative of that, which is going to give you negative half this thing of n equal to 1, negative 1 to the n, 2 to the n, 2x over 3 to the n. Why did I have that n plus 1 over there? So it's kind of confusing of how I get. Okay, this is pretty confusing as well. Couldn't really think of one of the reasons I can just get this thing wrong in whatever I have the representation of here. I think I make a mistake with having. I think I miswrite this part, because when you have going from that to that, take derivative of that, you're gonna have a negative for sure. I think I make a mistake noting down. Anyone have a representation of 1 over 1 plus x square? It's going to be this. When you take derivative of 1 over 1 plus x, and then you prime that one, you're gonna have 1 plus x squared. You have 0, 1, 1, 1. So you're gonna have negative 1. So it's gonna be a negative. And so I think I make a mistake with writing down that on my own notes. Negative 1 to the n minus 1, x to the n minus 1, and then you multiply n. Okay, so I have that one, and then that one, as I said, is going to equal 2x over 3 to the n minus 1. Multiply n minus 1. Okay, my mistake for n multiply. Oops. This one is multiply n. And so that's when I see you have also the n minus 1 here. Multiply n. Yep, I see the mistake that I make. Multiply 2 over 3. And so this thing end up giving me so you have 0, 1, 2, 3. So you're gonna have negative 2 for sure. And then you have this one is gonna give us the integral, the series from negative 1 to the n minus 1 over 3 to the n minus 1. Still don't understand why I don't get the answer. Even though. Check everything and make sure that's correct. This 2 is going to cancel out with this 2. And you have, okay, this one is equal 1 over, oh no, it's going to equal the series, n equal to 1, negative 1 to the n minus 1, 2 to the n minus 1, x to the n minus 1, multiply n, divided by 3 to the n plus 1. So then this one, we have 3 to the n, because this 3 and then this 3. We have 2 to the n minus 1, x to the n minus 1, and n. So the only difference that I have here is 3 to the n plus 1, which I couldn't even understand why I don't get that. But it comes pretty close, so I guess I make some algebra mistake somewhere. I don't think there's negative 1. What do you mean? Like, what negative 1 that you're talking about? It has to be, because Yeah, because this is the plus, this is not a minus, right? Yeah. And so when you go from here to here, 3 plus 2x squared, and you have a negative 2 over there, negative 1 over 2. Actually, you can have this as n minus 1 or n plus 1. It doesn't really matter. Here it is going to be n plus 1, but still it's going to give you the same answer because it's going to be going from negative 1 to 1 anyway. And these are negative 1 squared, which is 1 different from one another. Shouldn't make too bad, but what I'm concerned is whatever we have in the denominator, because it should end up with the same answer regardless of what we're doing. Still, I don't understand why I don't get that answer. um so yep, no problem. I'm gonna, if you guys wanna leave this section, that's fine. I'm gonna figure this one out. I'm really determined to do that. Let's think about. Yeah, but then you have the general idea of how to do this thing. So there are two ways you can do that. Starting from the series that you already know and just try to replace x with whatever expression with x that you have this time, or you can derive it from like an easier function. So it shouldn't be like a challenging things to do. I just couldn't think of a way why I'm not getting the answer here. Yep. I'll try to figure this thing out. Maybe send it to Dr. Cash and ask her to like maybe correct me. But yeah, if you don't have any further questions, I'll end the sessions here, and there's no next week that we can see one another. But good luck with the final exam. Yep. Have a great exam, guys, and maybe I don't teach 230 and 231, but anytime you have questions, feel free to email me. If I remember it, I'll try to help you guys out. Other than that, I'll see you.